Hello everyone. Hope everyone is doing well. Everyone is taking care of themselves and their family members, and no one is getting out of their house except for getting essential things. Okay, so this is our online platform to conduct classes. And one disclaimer here, please listen to me well. Those who are able to watch this video and those who know some of their friends living in remote area and they are not able to watch such videos because of less internet speed or any internet issues, convey my message to them that it's completely fine if they're not able to watch such videos, but they have to stay home. They are not going out of their houses just to watch this video or to search for speedy internet. So please convey my message to them. Somehow it can be managed later. Alright? Okay. So as you remember, this subject is problem based, and possibly the problems which are possible or to deliver on this platform, only those problems I'll be discussing here. So theoretical part of the first unit, most of the parts we covered. A quick recap we'll have here. We begin with this topic statistics, meaning which gives you information or status about some object or some real-time object, and characteristics and functions of the statistics we covered. Then sampling and census enumeration, that is the conducting the statistical investigation of one particular population. Okay, so there are two types. One is you cover every object in the entire population. The information of every object is collected, that is your census enumeration. On the other hand, we have sampling. So objects are chosen randomly from the entire population. In a way, it covers the population in the uniform way, covering all the parts of the population. So that is something called as sampling. So now both of them are used to collect data. Now once this data is collected, now the data it's in the raw form. So the reason we have collected this data to have some kind of analysis on this data. So this data which is collected, which is in the raw form, cannot be used directly for any kind of analysis. So there has to be organization of this data. So this data which is collected may have some unnecessary parts or unnecessary entries, may have some null entries. Some of the data of some particular object may not be in the same format for other objects which is already taken. So on one common base, this data has to be organized. And once this data is organized, then the next thing is to classify this data. So this classification is based on some criteria. So one has to first finalize the base for the classification. So now this differs from one data collection to another data collection. So if the data collected is of the employees of one particular organization, then it can be classified based on their qualification, it can be classified based on their marital status, or it can be still classified based on their designation. So these can be possibly basis for classification. If data collected is of the students, then it can be classified based on the region they come from, or it can be classified on their previous results. So that can be the base for the classification. So the reason for which the data is collected, the reason for which data will be used in future, that reason defines this basis. So this base for the classification largely depends on the reason for which data is collected. Okay, so now once this data is organized and classified, then it can be put into the form of suitable statistical table. So once this organization of data and classification is done, so that mainly gives you three benefits. The first one is unnecessary details are eliminated. Okay. Then the second one, the points where you have similar data and dissimilar data, those points are seen very clearly when you organize and classify data. And then the third point, which is very important, once this data is put into the form of statistical table, that gives you the platform for the comparison. So comparison is the base for any kind of analysis you want to do on any kind of data. So once it is put into the form of statistical table, then thereafter your analysis of data starts. So that basically gives you the platform for comparison, and then in results you can have the conclusions. So all over this data, once it is put into the form where statistical functions can be applied, then thereafter analysis starts. So this much is the theoretical part we covered now. Okay, now hereafter we'll take some examples and we'll see how those examples, how we can apply the classification. Example we have taken for making classification and tabulating the given data. So this is the marks of 36 students in one subject called as statistics. This is given to you. So if you have one look or one glance over all these values, then you may understand that some only few entries are there which are lesser than 20, and few are there which are near to 50. So assuming that 50 is the maximum here as of now, and 17 might be the minimum one, and rest all entries are in between this. So some major observations are always possible by looking at this entire data. Now, when you calculate the frequency for these values separately, and when we put them into the form of class intervals, that time you will understand how this data is distributed among these ranges. Okay, so now here I have already written the marks which are present in this list. Now for all of them, so there are around 17, 18 distinct values, and these values are nothing but repeated, and we have got here total 36 entries. So now here we will write down the frequencies of every such value from this table. So 17 is appearing once, so this is the tally mark, this way it is, one pipe symbol. 18th is also appearing once, okay. 20 is appearing once, and 21 is also appearing once. Then we have 22, 1. Then you observe it here as well for the second time. Then you observe here as the third time. Then we have fourth entry as well. Then we have fifth entry. So the tally mark of 5 is this way when we reach for 5. So this way, this indicates it's a 5 count. In 23 we find them 2, okay, 2 tally marks. Then 25, 26, 27, these all three of them are 1, 1, 1 each. Then 28 we find 1, then second, then third, then fourth, then fifth, this way, and also we have 6. We have 6 times 28. Then 30 is 1, 32 is 2 tally marks, 33 is ones, 34 is ones, 37 and 38. 38 is found 2 times, 39 is ones, 42 is ones, 47 is 1, 48 is 3 times, yeah, and 50 is twice. So this way we have calculated the frequency. Let me write it in the numeric form. These are the tally marks. So this is 1, this is 1, this is 1, this is 5, and then 2, 1, 1, 1, this is 6. 1, 2, 1, 1, 1, again 2, this is 1, this is 1, this is 1, 3, and then 2. Okay, so now total it makes 1, 2, 3, 4 plus 5, 9, 11, 12, 13, 14 plus 6, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 plus 3, 34 plus 2, 36. So 36 is your total frequency, and we have here 36 entries. Now this way you can understand. So we have got only 18 distinct marks and they are repeated, and those all together they are making 36 entries. Now this same data I will put it into the form of class. Now what do you mean by a class? So now here we have written the frequencies of individual marks. Okay, so now I can group some of them, like I can group 17, 18 and till 20 together. So this I will have one group and I will have the frequency 3. Then I can have 21, 22, 23 and 25 as next group, and then have the total frequency as 1 plus 2 plus 5 plus 2 plus 1, 9. Then similarly I can have the next group, so this way. So now rule for making class intervals is all classes must have same width. So and the width should be of any convenient number. So we usually don't take width of such like odd number. We have to take width which is convenient. So 5 can be one possibly width of the class. So now looking at this, we have got the 17th as the minimum number. So if you start with 17, then you may have the plus 5, the next limit as 22. Okay, so instead of having in this way, I can have from 15 to 20 and then 20, 25, 25, 30. So this way I can make the classes. So here I make classes this way. This is 15 to 20, 20, 25, 25, 30, 30, 35, so as 50 is my largest number in this. So I will have 3 plus 3, 6 plus 1, 7 classes. So now if you look at this, now one question. Now 20 is here as well and here as well. But you cannot include 20, frequency of 20 in both of them. Either you have to include it here or you have to include it here. In case if you want to include 20 here, then you should not include it here. Then similarly 25 should be included here, should not be included here. Same thing about all this. So now this is called as the lower limit of the class, and this 20 is called as the upper limit of the class. So you would define whether you are excluding lower limit or you are excluding upper limit. So these both of these ways you can have the classes. So now for timing we will have the classes where we are excluding the upper limit. So now here I mentioned upper limit excluded. So now here this is my class, and then here I will have frequency. Okay, so now in this 15 to 20, so 15 to 20 means 20 we are excluding the upper limit, so only 1 plus 1, 2 will be the frequency. Then 20 to 25, that means actually 20, 21, 22, 23, 24. 25 we are excluding as it's the upper limit. So 20, 21, 22, 23. So only this much. So this 1 plus 1 plus 5 plus 2. This will give me 9. Then 25 to 30. So again excluding the upper limit. So 25 here you have to start 1 plus 1 plus 1, 3 plus 6, 9. This we are excluding. That will consider in the next class. Then 30 to 35. So again 35 is not there. So 1 plus 2 plus 1 plus 1. So which gives me 5. Then 35 to 40. So 35 is not there. 37, 38, 39. Only these three. We can make it all together 4. Then 40 to 45. 42 only will be considered. So this gives me 1. And then 45 to 50. So 45 to 50. So 50 is upper limit. So we are excluding it here. So 47 and 48 altogether gives me 4. And then one more class I need to add for 50 to 55. Then this gives me 2. So let me add all of them. Then 2 plus 9 is 11, plus 9 20, plus 5 25, plus 4 29, plus 130, 34, and this also gives me 36 as total frequency. So now the same table you can write where you would exclude the lower limit. So lower limit in the sense 15 will be excluded. You are not going to include 15. So 20 you will consider here, which we had considered here would be considered here. So that will give you the different frequencies. So all of you please try for this. That will give you different frequencies, and you may not have this class. You may exclude this class because when you exclude lower limit, upper is considered here. So one class might be excluded, but total frequency remains same. Okay, so that also you keep a track. So total frequency has to remain same. So now look, what do you understand by looking at this table? So as you start, the start range is with frequency 2. Then the next two classes is with the highest frequency, that is 9. Then frequency has came down to 5, then 4, again very down to 1, and again then 4. So somehow this way it is kind of curve of frequency increasing and again decreasing. Little it has increased and again decreased. So this way you would understand the overall how these values are dispersed among the highest and lowest range. So that is what this your frequency distribution table gives you an idea about it. So also you prepare the table for the same frequencies where you exclude the lower limits. So that's all for today. So you have learned about how to calculate frequency, how to select class intervals, and how to present data into the form of frequency distribution table. Okay, so that's all for today. Examples for on this same concepts I'll be forwarding on the group. So please practice those all examples. For if you have not understood any part of this or any queries, you can comment it in the comment section, or you can ask it over a call that can be answered. So that's all for today. So we'll meet in the next video. Till then, stay home, stay